Good morning, sports fans, especially Cardinals fans. We are starting section 1.6, which is graphical transformations. And the reason they had you learn about the 12 special types of functions in section 1.3 was so that you could shift them around in different locations and you could tell basically what the graph was going to look like just by looking at the equation. So today we're going to talk about transformations, vertical and horizontal, moving it up and down. And I usually say, shifting. Shift happens. Reflections across the x-axis, vertical and horizontal stretches and shrinks, and when you combine them all together. Studying transformations helps you to understand relationships between graphs that have similarities but are not quite the same. They've just been shifted. So in this section, we'll relate graphs using transformations, which are functions that map real numbers to real numbers. Rigid transformations just move the graph, but the shape doesn't change. It doesn't stretch at all. Non-rigids are the ones that stretch or shrink the graph. All right, so I gave you this sheet, your notes. They're all listed right here. They're also in your textbook, but you're going to be using this to complete these notes. So hopefully you have your pre-printed notes with you, and it has all the different transformations listed. And you have to be able to tell whether the number added to or subtracted is within parentheses or put on at the very end. If it's within the parentheses, that's going to be a horizontal shift. If it is tacked on to the end after you apply the function, then you're going to be moving that function up and down. So let's look at this one. You can see that the original function would be x squared. So you don't have the number inside the parentheses with the x. It's tacked on to the end. So when you're looking at your little guide there, you would look at the one that is f of x plus k, which is shift. And this, since you're adding 6.3, it'd be shifting up. This one, you can see that the number is grouped within the parentheses, so you're going to apply it before you square it. And that's key because that makes it a horizontal shift, and it's going to be a shift right. If you were looking at your little guide, you'd see that you have h of x equals f of x minus h, and it right to the left it says a horizontal shift of h units to the right. This one has all kinds of stuff going on. First off, you've got a -2 times the whole function. You're subtracting 3 from the x, that's a horizontal shift, and you're adding 7 at the very end. That's going to be a vertical shift. This is a stretch and a reflection at the same time. When you take the opposite of it, and if you look at your little paper there, the opposite is like the very last one in this group. It says y equals the opposite of f of x. Well, it's actually 3 up. Reflection over the x-axis. So this is what you're going to be doing when you're looking at your homework. It's going to reflect across the x-axis. That's the negative. Vertical stretch of factor 2. That's this 2 that's out there. Whoopsies. Negative means to reflect something across the x-axis. The 2, when you multiply it by the function, gives you a stretch factor. And shift right because it's minus within the parentheses, and then you add 7, that's a shift up. So it had several things going on. All of these together would combine to make reflection, vertical stretch, right shift, and a shift up. How do you transform this x minus 2 cubed into the opposite of x plus 2 cubed? Well, when you see this opposite here, right away, that is a reflection across the x-axis that we just saw. The -2 becomes a +2, so it's actually a shift. To get back to 0, it's 2. To do 2 more, it's going to be 4. So is it a shift left or a shift right? Well, you'd be adding 4 in here. So when you look at this, we know we're going to shift it, reflect it across the x-axis and shift it left 4 units. The x's are the opposite of what the y's are. You normally would say if you're going to a positive direction, you're going to the right. But you know how your x's always mess stuff up, so try to keep that in mind. X's always mess stuff up. So when you look here, instead of saying, okay, I'm adding 4, I'm going to go to the right, you add 4, that means you go to the left. Could also be accomplished in one reflection across the y-axis. So when you see that If you graph both of those on your graphing calculator, that's also an option. But this is how you would use the guide. You do this first answer. So let's sketch the graphs by hand. Now you were supposed to know what the shapes of these graphs look like. So the x cubed, there's three main points: -1, 0, 0, and 1, 1. So what's going to happen to this if you subtract 2? It's going to shift down 2 units. So this, all we do is we take each of these points and shift them down. This was the original x cubed, and then what's going to happen is I move those 3 points down and sketch it. So it just shifts everything down 2 units. X plus 4 quantity cubed minus 1. This would be a shift to the left 4 and down 1. Look at your sheet if you're not sure. See how I got that. So you could also, so that's what this is saying, down 1, left 4. So if you know what the original x cubed looks like, then you just take each of those points, go down 1 and to the left 4. So he's going to be over here. This guy would shift 1 to the right, and it'd have a stretch of 2. I would do the stretch first. The stretches are harder to do. Stretch factor of 2 and right 1. When you're doing a stretch factor of 2, you leave the x coordinate the same and you double the y coordinate. So I would leave the x the same and multiply the y coordinate by 2. That's multiply the y coordinate by 2 in order to do this stretch factor. So here's what the vertical stretch would look like, and then you would have to move it to the right 1, and there's your final graph. You might dash this one and then just when you shift it over. Shifting is the easy part. The stretching takes a little more finesse. Okay, now on this one on your paper, it says that the graph is that of a function y equals f of x that can be obtained by transforming the graph of y equals the square root of x. Write a formula for that function. So when I'm looking at this one, I know the square root of x looked like this. You have to know what the original graph looked like. So here's what he looked like. It was going like this. So when I look at this graph, I know two things have happened. There's been a shift and a reflection. This guy's flipped over the x-axis, and it's been shifted to the left 1, 2, 3 units. So to go backwards, I'd say reflection over the x-axis is negative, the opposite of the square root of x there. And then it's shifted left 3, so it's the opposite of the square root of x plus 3. You'd group that with the x. All the shifts, the horizontal shifts, are grouped with the x. So that's it for that one. Find the equation of the reflection of f of x across the x-axis and the y-axis. Look at your sheet. Refer to your sheet. What is the reflection over the x-axis? That's the opposite of the f of x. So all I do is take this f of x and take the opposite of it. So answer to part A is opposite of f of x equals the opposite of that whole thing. You can distribute the negative if you would prefer, but either answer is perfectly fine. The B part, if it's a reflection over the y-axis, the f of negative x. This one you put a negative x, or the opposite of x, in for each of these x's. So all we do is we substitute that in, and we have to simplify this one. The opposite of x cubed, a negative times a negative times a negative, is going to be a negative. Anytime you have a negative to an odd power, it's going to be negative. So when I simplify that, I get the opposite of x cubed minus 5x squared, because an x squared won't change the sign in front, plus 3x plus 2, and you're done. That easy. Let's talk about these. These absolute value ones are kind of funky, and I like them. Look at your sheet. It says absolute value of f of x. That reflects what's below the x-axis to above the x-axis. So if I look, what's below the x-axis? That's this guy right here. All these negatives are going to be positive. The positives stay positive. So I just reflect that portion of the graph up here. That would be its reflection. If I look down here, I reflect that point up across the x-axis. So my final graph is going to look like, and then this portion is negative, and it's going to reflect up. So my final graph is going to look like this. Boom, bitty boom, bitty boom, bitty boom. The red graph there. So I think that's kind of funky, don't you? All right, and the next one, f of the absolute value of x, means that when you put in a negative x, it becomes positive. So what this does is it reflects the right portion across the y-axis. So when I look at this guy, the right portion across the y-axis, this is the right portion of the graph. This hump right here. It's going to reflect over to make this blue hump. So it just took this right portion, and it's going to be identical over on the other side. So my final graph is going to look like that. All right, that's it for 1-6, and I will see you later. Hopefully you're ready to roll on the homework. Remember, refer to that first chart in your notes. Bye.